All right, so for this question, we've got this U space, which is basically defined to be x times p of x for any polynomial p of x in that P2 space. So if you forget what this is the set of all polynomials of degree 2 or less. And we're asking if this is a vector subspace of P3. So the best way to do this is probably try to figure out what something in U actually looks like. So if Q of x is in U, then Q of x equals, well, we know it's x times P of x for some P of x in P2. And just what that looks like, well, it's a polynomial. So I want to keep things as arbitrary as possible. There's not really any restrictions on what P of x looks like. So I can write this as something of the form ax squared plus bx plus c for some real ABC. So now it's a little bit more hands-on with P of x. I've got unknowns. So I've written P of x in terms of its coefficients, which are unknowns. They can be anything because this could be any polynomial in P2. So what I'm going to do now is regroup for the coefficients, because that's generally what we like to do to describe spanning sets. So I'm going to regroup for the coefficients. In this case, that's your ABC. That's not much regrouping going on here, but what I get is ax cubed plus bx squared plus cx. And if you actually see this, you can see that q of x is any combination like this, which does basically mean that it's being described as being in the span of, well, essentially x cubed, x squared, and x. So this actually tells us u is the span of x cubed, x squared, and x. And since it is a spanning set, we can say that yes, it is a vector subspace of P3.